Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Anis Farhana binti Sani, metric number 2020-887206. I am from EC1101L.
And my name is Sita Ashata Anis binti Basri, and my metric number is 2020-843962. And I am also from EC1101L.
My name is Farah Alisha Muhammad Sadi. My metric number is 2020626154, and I am from EC1101L.
What is differentiation? Differentiation in calculus is process of finding the derivative or rate of change of a function, in contrast to the abstract nature of the theory behind it. The practical technique of differentiation can be carried out by purely algebraic manipulations using three basic derivatives, four rules of operation, and a knowledge of how to manipulate functions. Have you guys think why we need differentiation? We need differentiation to calculate the profit and loss in business using graph, to check the temperature variation, to determine the speed or distance covered such as miles per hour, kilometer per hour, etc. With the help of differentiation, we are able to find the maximum and minimum values of particular functions, such as cost, strength, amount of material used in a building, profit and loss.
So what is row theorem? Row theorem is suppose that fx is a function that satisfies the three conditions. Firstly, fx is continuous on the closed interval a and b. And secondly, fx is differentiable on the opening interval a and b. And lastly, fa is equal to fb. Okay, and last one, then there is the number c such that fc is equal to 0, a is lesser than c, but c is lesser than b, which is mean that c is between the coordinate a and b. The Rowe's theorem states that if fx is differentiate on a and b, continuous on a and b, and fa is equal to fb, then there is at least one point c in ab where f prime c is equal to 0. The information says fx is equal to x squared minus 6x plus 5. Find the value of c in the interval 1, 5 that satisfies the above theorem. So, firstly, for the step 1, we are going to come up with the information. So, what is the information? The information says that fx is equal to x squared minus 6x plus 5, while the coordinate is 1, 5, which is mean that 1 is a and 5 is b. For the step 2, firstly, we have to find the fa and fb. So, in fa, which fa is 1, so f1, and substitute in the function of 1 square minus 6 minus 1 plus 5. And then from here we can get 0. In the fb, we substitute the fb with 5. And then 5 square minus 6 times 5 plus 5. And then we can get 0 also. So in here, we can get fa is equal to fb. For the step 3, firstly, we have to find the f prime x. And then we can get f prime c. And the last one, we have to find the f prime c is equal to 0 to get the c. So let's go with the first step. So f prime x is 2x minus 6 plus 0. Okay, this is f prime x, 2x minus 6. And then for the second step, f prime x, from the f prime x to x minus 6, we change it to the f prime c to c minus 6. And then for the third step, f prime c is equal to 0. Then from there, 2c minus 6 equal to 0. And then we can get c. How to get c? C is 6 over 2, and then c is equal to 3. From here, we can get c is between the coordinate a and b, which is mean that c is equal to 3 between coordinate 1 and 5. That's it. This is the answer.
Theorem for differentiation. Suppose fx is a function that satisfies both of the following. First, fx is continuous on the closed interval ab. 2. Fx is differentiable on the open interval ab. Then there is a number c such that f prime c equals to fb minus fa over b minus a, and c must between a and b. Okay, so this is the question. The mean value compulsory theorem for differentiation states that if fx is continuous on a closed interval ab and differentiable on the open interval ab, then there exists a number c in ab such that f prime c equals to fb minus fa over b minus a. If fx equals to x plus 1 over x, find the value of c in the interval half 2. Step 1 is identify the values of a, b, and fa, fb. To find the value of a, the beginning of interval, we must compare here with here. So our a is half. To find the end of the interval, we compare here and here. So our b is 2. After we find b and a, we can solve b minus a. So b equals to 2 minus a equals to half. So we get 2 minus half, we get 3 over 2. After that, we need to find fb and fa. To find fb and fa, we need to refer fx. From the given question, fx equals to x plus 1 over x. From here, we can find our a. So our a is 1 over 2. Means that we need to find f half. So we just replace half into variable x in fx. After we solve it, fa equals to 3. Then we need to find fb. Our b is 2. So we replace 2 into variable x in fx. So after we solve it, we got fb equals to 3 over 2. After we find fa and fb, now we can solve fb minus fa. fb equals to 3 over 2 minus fa equals to 3. 3 over 2 minus 3, we get negative 3 over 2. So now, we are done find the right hand side function, which is the value of fb minus fa and the value of b minus a. And we continue to step 2 to find f prime c. But to find f prime c, we need to find f prime x first. And to find f prime x, we need to differentiate from fx. So from the given function, fx equals to x plus 1 over x. We have single denominator here, so we can separate it. After we separate, we get x over x plus 1 over x. After we simplify x over x, we get 1. But we need to change 1 over x to x to the power of negative 1, so we can differentiate easily. So we differentiate fx, we will get f prime x. And then 1 will be 0. No need to write. But x to the power of negative 1, we must use power rule. So we move negative 1 to the front. So we get negative x to the power of negative 2. Why we get negative 2 here? Because the power negative 1 minus 1, so we get negative 2. So, then, we move negative x to the power of negative 2 to down using the properties of indices. So, it will be negative 1 over x to the power of 2. After we get f prime x, we can find f prime c. To find f prime c, we just replace x by c. So, we get negative 1 over c squared. Okay, at this point, we are done find left hand side, which is f prime c. From step 1, we done find b minus a, fb minus fa. From step 2, we done find f prime c. So from here, we replace f prime c with negative 1 over c squared. We replace fb minus fa with negative 3 over 2. We replace b minus a with 3 over 2. After we simplify the right hand side, we get negative 1. And then we cross multiply. We get c squared equals to 1. We move square to the right hand side, then we get square root. When we have square root, we must put plus minus to the front. So we get c equals to 1, c equals to negative 1. We must remember c must between half and 2. So c equals to 1 is valid in interval half 2. And c equals to negative 1 is invalid in interval half 2. So this is the final answer.
The conclusion of Rolle's theorem says there is a c in coordinate 1, 5 with f prime c equal to 0. We have been asked to find the values of c that this conclusion refers to. Therefore, c equal to 3 is between coordinate 1, 5. The mean value theorem states that if a function f is continuous on the closed interval coordinate ab and differentiable on the open interval coordinate AB, then there exists a point C in the interval coordinate AB, such that f prime C is equal to the function's average rate of change over coordinate AB.